So graphing in science, there's different types of graphs. You're going to need these graphs when we go ahead and graph our heart rate lab. There's a line graph that's going to show change over time. So if you're looking at this image right here, you can see that there's a certain amount of days, and then it's showing what's happening over the days. A bar graph compares data. So you're looking at, all right, it's more visual. And then a pie or a circle graph shows a part of a whole. You use that when you're talking about percentages, stuff like that. Tell me really quickly, looking at these graphs, what's wrong with them? Ramir, thanks for raising your hand. This one? This one? Yeah, the numbers are crazy. I can't see what the numbers are. And that's partly just because of quality, but also, like, who's going to look at that and be like, oh, yeah. Like, that big of a number, that's crazy talk. The values are weird on the axes. You got another thing for me? It's not what? It's not linear. Your graphs might not always be linear. So I'm not going to, I know this one looks extra weird because it's steppy. But usually, yes, you're going to have a nice rounded curve. What about this one? Could you read the data on that one?
No.
No, ew, look at it. It's all squished down to the bottom, so what's wrong with it? Yeah, how would we change that? What is that called?
Scale.
Its scale is jacked up. Yeah, both of these have really weird scales. It would look better, like Ramir was saying, that one would look better if it was a nice rounded curve. And the scale, I don't know if you have to write this. Nope, it's already written for you. Is the axis intervals should be picked in order to use the whole page to better display and interpret the data. I want you to look at this data, this question here. Does this have the same data? All right, so our first data point here is 3.
There's 3.
That's 2.
There's 3.
It looks like 3 to me. This one's 10.
There's 10.
There's 10, and then this one is 12.
There's 12.
Would that be maybe 12? So it is the same data. So go ahead and where it says, do they contain the same data? You want to write yes, they contain the same data. Yes. But which one is better, do you think? The one on the left or the one on the right? You would be able to find the slope maybe a little bit better here. What else? There's multiple things that's nice about this one. Ramir, give me another thing. We could make a trend line that would be a straight line. If you have data like this, I expect it to be like the one on the left. Because it's more precise, I'd be able to get closer into the data, and I would be able to get a slope easier. If I drew a line through this, it would be easier to find the slope versus this where there's a huge jump between 0 and 5. Whereas down here, it's 0 and 2. I know what's right in the middle. Does that make sense? It would be easier to use those numbers on the one on the left. All right? So what I need you to do, I need you to connect the dots for this guy. Connect those dots.
I got you.
You have that picture down on the bottom. Connect those dots for me.
You have to show us that last data is 0.
So I guess we just marking this here.
Yeah, just add that 0 on there. Good eye. I'm sorry. Must not have copied well. All right, so you add that 0 down at the bottom, and then you're going to connect the dots here. Could you find the slope of this?
Yeah.
The thing is, finding the slope for this, and I think we kind of demonstrated, it's difficult for a line like this where one part has, from 0 to 1, it has one slope, right? It has one angle here. And then from 1 to 2, it has a different angle. And then from 2 to 3, it has a different angle. So it's hard to get the slope of those lines because there's different segments of it. That would be a lot of work. So what I propose is that you find the line of best fit.
Yes, that's what it's called.
All right, you're going to make a line through your data, and you can hit dots on it. So you're gonna draw. You can use another paper too, or a folder. Like Jay is being resourceful. All right. You're gonna draw a line through your data. You're gonna hit as many points as you can. But if there's one below, you're gonna make sure there's one above your line. Does that make sense? So you're drawing a line through your data. You're hitting as many points as possible. But if there's one dot below, you need to make sure there's one dot above. It says here, slope and interpretation. Science is the application of math. I always say if science and math were people, they'd be in love. All right? So slope, we see that in as M. It gives a relationship between independent and dependent variables. All right? It's giving us that relationship. So down here, you get, this graph is showing you miles per hour, and that line is showing you miles per hour. Showing you how far you're going over a certain amount of time. Okay? Using this graph. So go ahead. You see this, you have this same graph, density of shale, right here. Do yourself a favor. With the ruler, since you still have it, draw your line of best fit. So I have it starting at 0. It's going through this data, hitting that last dot there, and then I have one dot below and one dot above. Make that happen.
I got you.
Beautiful. That when you're using a graph, I think, Ramir, you're the one who said this, right?
Yeah, probably.
Your slope, one way to find it, there's multiple ways to find it, but one way to find it is rise over run. So I need you to write that down right here. It says, above your graph, using a graph, M equals, you're going to write rise over run. Right here in your notes. When you're using an equation, which we're going to have to do, we can take that rise over run. You're going to rise up your y graph, so y2 minus y1, and you're going to divide by your run, which is your x. So x2 minus x1. Write that down.